This is a brief, helpful hint on book set 3D problem number 1. In a scene in an action movie, a stuntman jumps from the top of one building to the top of another building 4 meters away. After a running start, he leaps at an angle of 15 degrees with respect to the flat roof while traveling at a speed of 5 meters per second. Will he make it to the other roof, which is 2.5 meters shorter than the building he jumps from? First thing you have to be able to do is visualize it. Let me draw the picture for you. If that helps and that's all you need, stop the video right there and work it out on your own. This is the situation. You have your stuntman right here. You have the angle with which he's leaping off the building. You have the distance between the buildings, and you have the lower roof on the other side. What are you really looking for? Well, what you're really looking for is where on the y-axis is this person at the point when he hits 4 meters on the x-axis. So thinking about it this way, well, wait, before I go any further, if that's all you needed, if that got you out of the mud, pause the video, go away, and work on this on your own. If you still need more help, keep listening. We can imagine a couple different flight paths for this person. We could go like that. We could go like that. It could be like that. Not telling you which is correct, but what you're looking for is to find out how far they have fallen, what's their delta y, when delta x equals 4 meters. If delta y is going to be negative. We assume, anyway, that they're going to be below the level of this first roof. If delta y is less than negative what? Let me erase all these ugly green lines. If delta y is less than negative what number, they'll hit the roof, they'll land. It's got to be less than negative 2.5. That means that they get to the 4 meter mark and they still have room to come down on that roof. Here, we can do that. Whee! So as long as they are not below negative 2.5 meters y displacement, when they get to x displacement of 4 meters, they're good. If they're at negative 3 meters when they get to that point, no more stunt person. So, okay, that should do it. If you're good, stop here. If you still need help, I'm going to list variables. So if you don't, pause the video. Okay, listing the initial velocities on the x and y axis. Sometimes it's easier if you pull that initial velocity triangle out like this, because then you can see that you have VI here, VIX here, and VIY there. Does that help? Okay, because your initial velocity on the x-axis should be VI cosine theta, and your initial velocity on the y-axis should be VI sine theta. I'm not going to give you any more than that. I'll stop the video. If you still need help, check in with me.